Again to our course, and this is to make mathematics easy to assist you as either a student at either a primary or secondary, or someone who want to improve your understandings in mathematics. I'd like to welcome you for today's session. So if you remember the last session, we talked about the place value, and during that we talked about the three digits. We talk about ones, tens, and the hundreds, whereby all they belongs to one period of the number, which is called the ones. So for today we are going to extend more our understanding in this category of the place value, and we are going to explore more numbers up to 12 digits, how to read, how to write, how to understand the place and the digit value in the given number. So without wasting a lot of time, let's just go straight to our PowerPoint, to our window, and proceed. Yes, so as you can see, let's go back now and proceed with our session in the board, and I want to take you back to the place value chart. So we have this chart and we talked about it previously. So what did we talk about over here? We checked the first three digits, and we said that the number in the first three digits, maybe the number like this, the first one represent ones, and the second one represent tens, while the last one represent hundreds position. And in this one, we say that this is the number of the units in that position. Like how you can see here, for the ones, that refers to the unit, which ranging from 1 to 9. They can be 1, 2, 3, 4, 5, 6, 7, 8, or 9. But once these digits reach to 10, then they form the next place value position, which called the tens, and you can even see it over here in this. So when we say about tens, we refers to the group of 10 units. When we talk about the tens, we refers to the group of 10 units. For example, when you talk about 20, then we have 20 separate units. So for this position here, we can say 210, simple like that. And when it goes to 100, the same applied. We have 10 bars of 10 bars of the 10 units, of which together they make a 100 units. So from that concept now, based on that concept, we need to add more numbers. So what happened when you add the next number? So when you add the next number and you get the 4 digits, maybe 1, 2, 3, 4. Okay, so here we have the number with the 4 digits. So we went to the next one. So here we need now to understand that this is 1000. This is 1000. Okay, this is 1000. So here we went to another number period. So to make number easier, we separate the numbers in terms of 40, in terms of the period. So you can see it over here. Let me show you the concept. You can see it over here that I can have the number like this one, 345, and I can have the number like this one, 1245. This number, it has the 3 digits. This number, it has the 4 digits. Let's add again another one here, 212445. You see, this one, it has 5 digits. So in numbers, normally to make the reading of a number very easy, we have, as I told you, we are talking about the number of Bezot we're talking about the number of base 10. So base 10 here we refers that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the digits which we are using in our number. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All together are 10 digits. All together are 10 digits, and that's why we say we are dealing with a number of base 10. So whatever the number we are going to make, we'll make the number based on these 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So from this concept here, just check that in order to read the number, we should know the position of each digits, and that position is what we call it a place value, and that position is what we refers to a place value. So under that circumstance, to make life easy, we have something called a period. We have something called the period. Period, this is the group. Period is the group of 3 digits. Is the group of 3 digits, okay, separated from right to the left. From right to the left, from the right to the left, from the right side to the left side. So for example, if you check our number over here, we count 1, 2, 3, so we put a comma here. So how many periods are there? We have 2 periods. We have this one, and then we have this one here. If you check this one also, we have 2 periods. This is the first one, and this one is the second. But here we only have 1 period, 1, 2, 3. So our comma will come here, but in this part here we don't have a number. So here we only have a 1 digit, 1 period. So under that circumstance, if we add again maybe a number, a bigger number, let's check now the bigger number. For example, I have 2, 3, 4, 0, 7, 8, 9, 2, 8, 9. Okay, so if you check this number properly, this number is quite bigger, but we can read that number based on the period system. Based on the period system. So you can check out from this number here. Let's go together. How many periods are there? This is the first one, comma, 1, 2, 3. This is the second one, 1, 2, 3. This is the 1, 2, 3, 4. So we have 4 periods. Here we have the second, the first one. Okay, so you can just see from there that we have the first one, we have the second, we have the third, and also we have the fourth period. Okay, so from those periods which we have over there, we have a system of reading it. So from the concept of the period, let me show you here what are you supposed to do for that party of the number which I showed you over there. Okay, so as I told you, we have this period, which is a group of 3 digits from the right to the left. The first one, it's called the ones, and the second one is called the thousands. Okay, thousands. And then the next one is called the million. And then after we have billion. We have many, but for us, we'll just focus with a number bigger to almost 12 digits. So for the ones, as you can see it over here, this one, it has it's ranging from 1 to 3 digits. And this 1000, it then range for the number which meets with a 4 to 6 digits. For the million, it has 7 to 9 digits. And for billion, it has 10 to 12 digits. So for example, from this one, you can have a number, maybe any number with a 1 to 3 digits, made with a 1 to 3 digits. We can just say 21, we can say 9, we can say 340, okay? So this one, it has 2 digits, this one, it has 1 digit, and that one, it has 3 digits, okay? Let's go together here. You can see from this is only 2 digits. This one is only 1 digit. And this one is the number made with the 1, 2, 3, only 3 digits. So for any number with this 1 to 3 digits, it belongs to the group, the first group of ones. But any digits which will follow for the number bigger to 4 to 6 digits, then that one now we are talking about thousands. So you can just see, for example, if we are talking about 4301, okay, 4,301. So this one, it has 4 digits. It has 4 digits. What about this one, 21,301? You see, this is just 1, 2, 3, 4, 5. This it has a 5 digits. Okay, so for the number with a ranging of the digits from 4 to 60, this belongs to thousands. So the same applied to here. Can you give me example of the number with 7 to 9 digits? Just try to write it down there. Okay, try to write down. Yeah. So let's check out here. If I have, maybe for me, I can give you a very simple example. 1, 2, 3, 4, 5, 6, 7. Okay, so the number like this, 1, 2, 3, 4, 5, 6, 7, this number, it has 7 digits. It has 7 digits. Okay, you can count it, 1, 2, 3, comma, 1, 2, 3, comma. Okay, so this number, it has 7 digits and it belongs to the million. You can see how many million? It is just 1 million. The same applied to this one. We can have the number like this. You see, so this number here, it has 10 digits and it is just 2 billion. So how to read it? How do we read? Okay, so as I told you before, if you can trace back, I told you before that we have yes, that let's go back to our chart previously. You can see it over there. From this chart, you can see those digits which those periods which we are talking about. You can just see it over here. Okay, 1, 2, 3. The first period, it's called ones. 1, 2, 3. The next one is called thousand. 1, 2, 3. It's called million. 1, 2, 3. It's called a billion. Okay, so the number next to from the right to the left, it is 10 times bigger in position to the previous one. So before we talk about the digit value, just understand that in each period we have the common place value position, which is ones, tens, and the hundreds. Ones, tens, and the hundreds. Ones, tens, and the hundreds. So that is the common one. So when we talk about consider maybe in the ones position, ones period. In the ones period we have ones, tens, and the hundred. So when you come again to thousands period, also we have 3 ones, tens, and the hundred. And also when we go to the million as well as a billion, then we still have 3 digits, which is ones, tens, and the hundred position. So for the ones one here, though this most of time we call it a unit. Just call it a unit, but the correct one is ones, because it can be a one unit, there can be 3 units, there can be 4 units. Remember that the word unit, it is standing for this square box, just a 1 square box. That's why here we say we have 1,000 units. We have 1,000 units. It means we have 1,000 these small boxes, which have been grouped into 10 groups of 100 unit bar, bar. That's why you can see it here. From this one, this is just a group of 10 units, which is called a 110. Okay, but here, this one, it is the group of 10, a group of 10 unit bar. This 10 unit bar, there are 10 of them over here. You can see there are 10 of them. And that's why this one, we call it 100 units altogether, which is called 100, okay? So from that concept now, just go back a little bit. I will take you back and forward until you understand the concept. So if we talk about the place value, if I have 3,489, you see 3,489. So check out here. This is 1, 2, 3. I put a comma. So the first one is ones. The second one is tens. The next one is 100. And the next one, remember that it goes now to the next period, which is called what? 1,000. Okay, 1,000. So instead of saying that once again, we just say 1,000. But from that number, if I add again another digits over here, maybe 0 and 2, 0 and 2, then the place value for this one here, it will be what? It will be 10. Remember that this is 110, 100, 110 and 100. Again, we move forward again. So here, because this one, the first one here, it is in the ones period, and the next one here, it is in what? Thousands period. So the first one here, we call it 1,000. The next one will be 10,000. 10,000. And then the next one here will be 100,000. I hope we are together. This is 100,000. Okay, 100,000. 100,000. That is the place value. That is the place, the value of the place, position where the digit is. A place refers to position where the digit is. So if I add again other over here, maybe 783, you see. So this again, this one here, this makes the next period, which called what? Million, which called million. So for this part of the millions, the first one here, we'll call it a million. Okay, and then the next one here, remember our concept, ones, tens, 100. So this one here will be called what? This one here will be called what? 10 million. Okay, and then the next one here will be called 100. Okay, 100 million, 100 millions. You see, so that is how the concept of the place value is. That is how the concept of place value is, and you should just understand it from that concept. So from here now, if I give you any example, any number, 34892. Okay, so and they ask you what is the place value? What is the place value of 4 over there? You should just simply count 1, 2, 3. You put a comma, so you know that this is ones, Now I'm in the group of 40,000. Okay, so this as usual, based on the concept which I told you, based on our concept, we know that this is ones, tens, 100. This is ones, tens, and 100 is not there. So direct, this, the place value for this one will be what? 4 will be equals to what? 1,000. How did I get 1,000? How did I get this 1,000? So you can see that this is ones, this is tens, this is hundreds, and this one, the next one will be what? 1,000, whereby this one is 10,000. 10,000. But for us, which one are we dealing with? Which one are we dealing with from there? We are dealing with 4. So our 4 belongs to 1,000 category, belongs to 1,000. So the place value of 4 will be 1,000. So simply from that, the same example, from the same example, what is the place value of 80? What is the place value of 80 there? So the place value of 80, we know that is ones, tens, 100. So that one will be equals to 100. That is what we call a place value. That is a place value. But from that concept, you can now go back to our table, and from there you can just understand it from there. So now let's just add another. Another concept, which is called the digit value. This is just a place value. We are going to check about the digit value. That specific digit. What is the value of that specific digit in the given number? What is the exactly value of the specific digit in the given number? So on the concept of the digit value, if we refer to now to the concept of the digit value, you should just understand that, okay, the digit value equals to that digit, okay, equals to what? Equals to our digit times the place value of the digit, times it is a place value, times it is place value. That is the digit's value. That is the digit value equals to the digit times it is place value. A digit times it is place value. So let's check out now here back. Let's go back here in our concept. So for example, if our digit is in that position over here, okay, maybe I have a number 346. What is the value of 4? What is the digit value of 4? So for that one, we know that 4, this is ones, this is tens. Tens means, what does the tens means? The tens means that here it is saying that the digits in this position, it is 10 times bigger than the previous digit. Okay, so this place here, it's called the value of 10, but this one, it holds the value of 10 times more than the previous one. So 10 times 10, you get what? 100. Get 100. Okay, so 100 means that this is the place value. Any digit over here, if we want to get the value of that digit, for example 3, we'll just take 3 times what? 3 times 100, which will be equals to 300. And that is what our concept of the place value means. When we say 300, we refer to 300 units. 300 units. So for the number over here, it's called a position of 100 units. 100 units, each digit within. Okay, so if we have 3, then it refers to we have if we have 3, like the one over here, then that means we have 100, we have 100, we have 100, we have 300s. Okay, and also the place value of the digits over here, it is 1000, 1000, 10 times bigger than the previous one. So this 1000, it means that if I have the number here, maybe 2, then it simply means that I have one group of 1000, I have another group of 40 of 1000. Okay, so to get the value of the digits here, maybe I have 2, 3, 4, 6. So the value of these 2 over here, it means I have to take 2 times what? 2 times 1000, which equals to 2000. Okay, we together there, we moving together. Yeah, just pay attention there. So for 10,000, it means that we have to multiply the digits over here, maybe 7. It means we have 7 10,000s group, 7 of them. So to get the digit value of the digits over here, we simply have to take this times the value. The same applies to all other positions. The same applies to all other positions over there. Okay, so from that concept now, don't forget that we have to consider in these groups, this it has 10, it has 1, sorry, the first one here is ones, then tens, then 100. The same apply to this one, it goes the same way, ones, tens, 100. And the same also here in the millions, it has ones, tens, 100. And this one, it has ones, tens, and 100. So here, this is 1000. Here, this is million. Okay, and this one is billion. How many digits there? If you remember, then 7 digits. 7 digits. Okay, so here is 1, this is 1000, this is million, and this is billion. That is a billion. Okay, so we simply add a group of 30 to the next. So here, this it's hold its own value of 10. This hold the value of 1. This hold the value of 100. So the same applied here also. So if you see like the number in a 10,000, so 10,000 means we have 10,000. Okay, 100 million, 100 million, 100 million. So you add 3. Okay, simple like that. Okay, 10 billion, 10 billion. How many zeros are there in billion? 6 of them. So 1, okay, and then simple like that. You see, so that is the how we are dealing with the place value. And if you want to check the number which is in this position, maybe 7. So the value of this one will be equals to 10 billion times 10 billion times 10 billion times 7, which will be 70 billion, which will be 70 billion. Okay, so let's check more examples under that concept. Okay, we have talked about those one. So if I have this number over here, okay, if I want to refer to the place digit value of 4, what is the digit value of 4 there? What is the digit value of 4? So here I'll take 4 times the place value of where the 4 is. So the first ones, tens, we are done with this one. Here we are in thousand. So ones, tens, hundred. So we have 100,000. We have 100,000. So times 100,000, what do we get? We get 400,000. So this is the value of a digit in that position. Okay, the same applied if someone asks you about what is the value, what is the digit value of 0. So 0 itself, it holds the position there. Okay, what is the position of 0? 0, the place value is 100. The place value is 100. Check out here. We have 3482069. So from this number, if you check it properly, this is ones, this is tens, and this is 100. So the place value, okay, place value of 0 equals to 100. But the digit value, okay, let's go back to the digit value. So the digit value of 0 will be equals to 100 times 0, which equals to 0. So the digit value is 0, but the place value is 100. So it's hold the position in the number. It's hold the position in the given number, and that position, it is meaningful. So don't forget the basic mathematical concept that any number, okay, any number times 0 equals to 0, but any number times 1 equals to that number. Any number times 0 equals to 0, but any number times 1 equals to that number. Okay. So based on that concept which we have studied about over here, I'm sure you will be able to find the digit value and the place value of any number. So before we move forward, the same concept of the place value is one which will assist you to read any number. Okay, so the numbers are being presented into three main formats. The numbers are being presented into three main formats. The first one is a standard form, the one in which we write the number, like how you can see it over there. That is the standard form of a number. But the next one is the word format, word form by words. Okay, so by words, it's very simple. What you have to do, just deal with the period of the number. So for example, as you can see our number over here, okay, how many periods are there? 3 periods, which is ones, and then thousands and millions. So here we can just say that we have 3,482,000 and 069. So you just read 3,482,000 and then 69. So always we separate by using what? By using a comma from one period to another. So 3,482,069. Okay, somebody can just say that in this, the last one, you can say ND 69. It's fine, it is still correct, ND 69, because there you are just concluding. So it is still correct. But another format is by using the expanded form. In the expanded form, we just multiply based on the digit value. So for example, in our number 382,069, so here we know that this one is referring to 9, this one referring to 60, this one referring to 00, this one referring to 2000, and this one refers to 80,000. Okay, 80,000, and the next one here, it refers to 400,000, and the next one here refers to 3 million. Okay, and to get the digit value, it is very simple. To get the digit value, it is very, very simple. The concept which you have to use is like this. If you are looking for the value of 8, digit value of 8, digit value of 8 over here, then I just turn 0, all the number to the, all digits to the right, I turn 0, and then I remove the one in front. So you can see like here, if I'm talking about this, it will be 60 because I turn this to 0 and then I remove those in left. But the one of this one here, 1, 2, 3, so it will be 2,000. Very simple. This one, I turn this full, so it will be 80,000. So for this one, how many digits are there in this side? 1, 2, 3, 4, 5, 6. So it will be 3, 0, 0, 0, 0, 0, 0, 3 million. Okay, so for the expanded form, we have to put this in addition format, in the addition format. That's why you can see it here. 3,480,2,069. Why we didn't put 0? Because any number plus 0 equals to that number. Any number plus 0 equals to that number, and that's why 0 was just omitted from there. That's why 0 was just be omitted from there. But the place value of 0 is 100. Don't forget that concept. So this number 3,482,069, 0 representing hundreds position. Okay, but the place value, value is 100, but the digit value is 0. Digit value is 0. Digit value equals to 0, but the place value equals to 100. The place value is the one which makes the difference of that one. If without this 0, we cannot say this is 2,000. Remember that if we don't have, if you have this one, if you remove this 0, then it will be 269. But by adding 0 over here, this becomes 1,000. So it makes the value worth 10 times bigger, worth 10 times compared to the previous position. So don't forget that concept. Don't forget that important concept. So there is where most of people are making a mistake. 0, as I still insist, 0 still hold the place value. Okay, it's hold the place, but the digit value itself is 0. So like you can see 702, we cannot say 72. We say 702. Without this 0 here, then it is 72. But because of this 0, it is not the same. Okay? It's not the same. Okay? So reading the log number is I hope you have seen there. It's all to deal about the periods. To deal about the periods, nothing else. And you remember that in the periods we split from the right to the left, from the right to the left. But in reading, splitting, we split from the right to the left. But in reading, we read, okay, from left to the right. So if I have the number, I will split it from the right to the left. 1, 2, 3, comma. Okay, if I have 1 here, 1, 2, 3, comma. You see? But if I split the same number from the left to the right, 1, 2, 3, I'll put comma over here. 1, 2, 3, I put a comma over here. So you can see it is not correct. It is not correct. You'll get something wrong. Okay. So splitting, we split from the right to the left, but in reading, we read from the left to the right and say the period name So for example, this number here, we split 1, 2, 3, comma 1, 2, 3, comma. We have 3 periods. Okay. So 3 periods refers to million, thousands, and the ones. So we have 507 million, and then we have 40,000, then and the 12 and 12. Okay, so first look at this, split from the right to the left, split from the right to the left, and thereafter read the number in each group of 40 3 digits as the way that you have stated it. And then after every group of 3, remember to add the period name. Remember to add the period name. And then after, at the end, we don't say ones. So don't say ones at the end. The ones at the end, we just have to skip it. So working example like this number over here, as I told you, so we can read it as 507,040,012. Well, this one we'll read it as 6,030,500. Okay. Yeah. So simple like that. So try those two over there. Try those two, and that one is the last one for your practice. And you can even ask your teacher to check if you wrote it correctly or you wrote it in the wrong format. Okay? Yeah. But the concept to bear in your mind, we normally use 3 digits. For 3 digits, from where? From the right to the left. Split it from the right to the left. Okay? Yes. Thank you so much for today. We hold up here, and then for the next session, we will just see. We'll check more now on the how to do now the rounding of the number, comparing the number, and the estimating the number. Okay, estimation, rounding, and comparing the number using the concept of what? Of the place value. Yeah.